Hey all, it's Mooch. Welcome to Minding Your Mechs. Today we are testing the Tauren Max and its extension tube. I have the usual setup. I'm drawing a fixed 30 amps with this electronic load from a power supply above it, and we look at the voltage across the atomizer's posts here on this meter, and you can see it's 3.5 volts right now, and when we press the button it'll read the voltage drop through the atomizer, through the mech, through the solid aluminum battery slugs, and then back out again. And then when I post the table with the power that's lost in the mech, I subtract the voltage drop of the atomizer and of the slug, and he's left with just the voltage drop or power loss in the mech, so you can directly compare them. And let's get started. The first, stay still. The first thing I want to mention is the packaging for the Tauren Max was incredible, because there's this really nice aluminum tube that comes with, and the bag. There's a key for taking apart the switch, part of the switch we can take a look at. They have the specs, but they don't have any instructions. I'd like to see some instructions, especially since it comes with the X chip, a protected module, so you can run this as a hybrid top, a pure hybrid top mech, or a protected mech with this up in the way. So I'd like to see some instructions for that. One nice thing that was fantastic with all the Taurens, the Max and the regular ones, is it comes in a very thick vacuum sealed bag, which is fantastic because you don't get this thing all patinaed and everything. It's no oxidation at all because it's been inside this thick vacuum sealed bag. So I loved seeing that. So let's get this out of the way and set this up for testing. Here's the switch, constant contact. And this has a lock that's unlocked, that's locked. Goes just a little bit, but unlocked. We want to see this go to 0 volts because there's no current passing through the mech. And what I do is to prevent any arcing damage, if there is any arcing, from affecting my readings as I continue to do the test, or maybe come back and redo a test, is I close the contacts and press this button, and a 2-second pulse of current at 30 amps goes through the mod, and we can read the voltage over here. Now, just for a reference, the Dreamer in brass, and this is painted brass, was about 0.112 volts, 112 millivolts. The clutch was about 0.165. Per slam piece about 72. The best I ever got was 0.032, 32 millivolts with the Broadside Mods Admiral in yellow brass. So also going to test pressing it in different places. See if that has an effect. And let's get started. I'm going to go to 0 and fire the pulse. 0.07, another pulse. 0.061, 0.059, and I'm slightly moving the finger around, just kind of different things that you might do when you're using it. 0.059, because that also kind of tests out the button, and so far it's very consistent. This is kind of just getting my thumb all the way over it and mashing it hard. Let's try dead center. 6.3, and it was 0.059, 0.63, so I'm going to call it a 0.061. And that is running a little bit better than the Purge Slam piece, better than the Dreamer. Dreamer was almost double that. And what's amazing, I'm thinking now, about that result is up in the top, and I'll show you a macro photograph, the top half of the threads had black paint on them, and all the rest of the threads had gold paint on them from the lettering up on top. And I was really worried about that interfering with the performance of this mod, but that was pretty good testing. It'd be interesting to see what happens if this 510 didn't have the paint in it. And let's put on the extension piece and see what we get with this. And this is in lock position. We'll unlock it, make sure it goes to 0 volts. It does. And let's press and fire a pulse. Wow, significantly worse performance by adding this. We were at 0.06 and now we're at 0.34. .345, and that is about 5 times the voltage drop. So this threading here, because the brass itself along here, that's just not going to be any voltage drop. That's a lot of metal, but those threads there, and that's pretty tight. I'm going to loosen up the button a bit, and okay, that is really tight now. Tighten this, unlock it, go to 0. Okay, that made a big difference. 0.23. 0.23. I'm going to call it 0.23. And that is about 4 times the drop of just this. But it's not terrible, because let's see, I'm thinking who else I had stacked with, and the only one I can think of is the Mechlife Arcless, the version 1, and that one was running probably about a 0.12 in stack configuration. This was 0.23. So this is taking away a lot of performance. I'm surprised on there, and it may be if you do more with the threads. These were cleaned to an inch of the life, about a half hour with never dull and toothbrush. The threads may not be engaging before this touches this point. So the threads aren't smearing and wiping on each other. But let's go on to the arcing testing. What I do for the testing is use a 0.1 ohm load, and we're going to use actually I'll use 21700. This is Molicel P42A. And what I'm going to do is fire 200 times, and then we're going to take a look inside the switch and check for arcing damage. If there is any. There may be none. Well, there'll always be a tiny bit. We'll take a look at how much damage there is. You won't have to watch the 200 presses. And firing 196, 197, 198, 199, 200. Yeah, okay. For this, we've got their tool. Never tighten this piece back in. These threads are tiny, so it's very easy to strip these when you're putting this back on. And what you have is the spring, and then you've got 4 clutch plates, and you've got a ball up in the top here that touches the battery through this contact, constant contact here. Then that ball comes down, touches the bevels in the middle here, presses the plates out to the side. Current flows through the housing, through the threads, and back up through the mod, through the atomizer, etc. And so the contact points are this ball, those bevel points, and the outside edges. And I'm going to take a look with a loupe, and I'll throw up some micro photographs for you to take a look. Okay, you can definitely see some arcing points on the bevels. Checking the ball. Yep, the ball definitely shows signs of it, even just kind of right through the grease. Several points. And let's take a look at, find the tweezers. Going to take out these plates, and we're going to check the outside edges here, where the plate touches up against. Nothing for this one. Nope. You can tell where it was pressing up against the outer brass edge, but no arcing marks. Even though this is a what they might call a constant contact or an arcless switch, that's only for the surface that's touching the battery. You're still going to have to go inside here and maintain these and clean these. Now the problem is with that is they use what they say is a conductive grease on the ball and in here inside the contacts to improve performance. So in order for you to wipe off or to use like a Scotch-Brite pad, these rough scrubber pads or something, which I love for taking off minor arc marks, you're going to have to remove the grease from here. Once you remove the grease, that may or may not affect performance. I don't think it'll make much of a difference. Now, I've talked to them about it. They use Japanese conductive grease. I think you can use any conductive grease you wanted. Don't use a ton. Just use a thin film of it all around the contacts, all around, the clutch plates, all around the ball. You can smack the ball out of here and then reassemble. Make sure to have the spring. Now, there's also, I can just dump those. You may have noticed there's more to this. There's a locking mechanism down here and a whole lot of machining. Now, the tool they give you does not fit this, so you can't use their tool. What you need is a separate pair of pin pliers to go inside here and take this apart. Because if you try to use ceramic tweezers, you're going to snap your tweezers. And I should really put this down. You've got an adjustment screw here that you can use a hex key, and that will lock this in at a certain height, which you use to adjust for different batteries. And then you've got this portion comes out. There's an O-ring on here and a bunch of machining on the inside, and then this piece. Now, these are ball bearings in small tubes that can just drop out, so you have to be very careful if you're going this far to take it apart. You should not have to go this far to do any kind of maintenance. If you do, just be very, very careful, because if you lose these, I don't know actually how it'll function. I haven't tried it with these taken out, but be very careful if you go into the bottom half of the switch. And I'm going to put this back together, and we'll take a look at the performance of the protection module. Okay, this is the X-chip module, and what this does is goes up inside the mech, or at least that's how I think it goes, because that's how it was shipped, and it lets you use an 18650, but offers protection through circuits in the base here, over voltage, under voltage, over current, etc., to turn this into a protected mech. And what we're going to do is compare the voltage drop using a 0.1 ohm load. Compare the voltage drop of this mech. Actually, I should put the addy on first. With and without the chip. So I'll take this out, what they call the X-chip module. Now, I can't use this setup here because it's incompatible with this chip, with the circuitry here. My setup, this is just, it's not a fault of this, it's just the way I have things set up. So we're going to use this meter, and we're going to read off the voltage drop. And what we'll do is we'll fire it with the chip and without the chip, and we'll be able to compare the performance of the two. Getting a little crowded here, isn't it? Okay. Molicell P26A. Works better if I put in the 18650 adapter. Okay, and let's fire it. 3.3. 3.3. 3.3. Okay, so it's 3.3 without the X-chip module in there. And now we'll use the X-chip module just to see how much performance it takes away. Unlock it, and 3.1, 3.1, a little bit less, but the battery's coming down some. So 3.3 and 3.1, the 0.20 volts for the X chip. And that's a decent amount. But to get the protection here, to be able to turn this into a protected mech, it's not going to fundamentally change your vaping experience to have another 0.2 volt drop. That's about the same drop you get when you add on. Let's get rid of this. Let's disconnect this. Get some room back here. That's about the drop you get if you add on the extension. So it's not some kind of fundamental thing that's going to destroy your vaping experience, but it does take away some of the performance, but you get the protection back. And that can be a great way for a new mech user to start off with this, get used to, locking and unlocking the switch, getting used to checking resistance of their builds on a regulated device first, essentially everything you do to start with a mech. And then as they get used to it and they know that they have an atomizer that they can use in a hybrid top mechanical mod, namely not a sub-ohm tank or something like that, but an RDA with a fixed protruding pin, then they can go and switch to a pure mech by removing the module and using like a 21700 or 2700 or an 18650 with the adapter. Overall, performance was good compared to some of the other brass out there, but unfortunately there was some paint in there and the performance of the tube, the extension tube, was poor. Something with the threads done or when it engages. Actually, let me see when we tighten it. Yeah, see, I feel this surface bottom out against that surface before I feel the threads engage, before I feel the threads smearing and breaking the oxide layers and getting a good contact. So I think all the connection is down in here, and there's paint down there. So there is some connection, of course, here and here in the metal and threads, but I don't think that's carrying a lot of the current. I think that's why we're getting such poor performance for this compared to the mech itself, which is a pretty good performer. Just keep the paint out of there. I love the packaging. I love the idea of this module. It's not, considering what it offers in protection, I'm not too worried about the voltage drop through this. And it's just up to you as to what you want to do in terms of protection, not protection, performance, not performance. Now, for the switch and having to use, maybe not having to use conductive grease inside here, that's up to you. But there is arcing damage. You are going to have to eventually take care of that. I did 200 clicks, and I would like to clean up what I had seen there. So you may have to do some wiping down almost every day with this. Otherwise, certainly I'd say once a week you want to do some maintenance. Open it back up, use their tool, open up just the top half, and you want to be able to clean the ball and those center points in here for the clutch plates. I don't want anyone thinking that this has some kind of tremendous, arcing damage. When I was talking about the damage that's here, the damage on the ball is very, very minimal. I wiped off all the grease and took a closer look. I'll throw up the macro photographs right now, and you can see the ball has very tiny damage, as little as I've seen in any other device. And for the clutch plates, there's a little bit of arcing marks there, but also very minor, and that was after 200 hits at 30 amps. So this doesn't require any kind of extra maintenance or anything over any other device. In fact, less than a whole lot of them. But eventually you are going to need to get inside here and wipe off the grease and then use a Scotch-Brite pad or something to take the arcing marks off, because arcing marks beget more arc marks. As soon as you get them, that creates high points. That becomes the high points from the damage become the parts to touch, and since they're very tiny points, it creates an arc a lot easier than if you have a nice smooth ball and nice smooth contacts here. So still, you need to do maintenance once in a while. Just don't lose the ball. I got a little curious and decided I wanted to see what the voltage drop was if I removed the conductive grease that was inside the switch here. And we had got 0.061 volt drop over here with the grease in. So I wiped the grease off, then used alcohol soaked tissue, went over the ball, went over all the clutch plates, the inside of the switch, essentially removing all traces of the conductive grease. And let's see what the performance is. We'll do a check. We want to go to 0 volts. We are, and we'll fire a 2-second pulse. Interesting, 0.042. Firing. So actually it's 0.043. 0.043, and it's more consistent too. Yeah. Okay, that is 0.043. That is about a 25% improvement in the voltage drop of this, and turns it into a nice performer, just about the same as the Immortal Mod's grip in brass, and better than the Purge Slam piece, and starting to get close to the Admiral. The difference between 0.042 and the 0.032 of the Admiral is very little, and that's with the paint that's on the inside of the 510 connection here. So this is a good performing mod. It can be even better. I can't say whether every single Tauren Max is going to run better without the conductive grease, or if the grease itself was getting in between the components. Because I did see, when I popped out the ball, I did see what looked like a layer of grease between the ball and the inside. And if there's a coating of grease in between these two, then they're not getting a good metal connection, because the metal on metal connection is always going to be most important. Also, I thought I saw just a little bit of grease in between the clutch plates and the outside ring. Again, nothing's ever going to be as good as metal on metal connection. So maybe the grease was actually kind of getting in the way, and just a thin film would be better, or nothing at all. I don't know. You can experiment with your Tauren, but right now, at least for this device, I get about a 25% improvement in the voltage drop from 0.061 volts with the grease to about 0.043 volts without the grease. That's all for today. Thank you for watching.